Welcome back to next session, students. In this session, we are going to discuss about smart sensors. So, as we know, smart means it can make decision on its own. So, here, what are all the different smart sensors that we are going to discuss in this session? So here, smart sensors, we have completed all these topics, and we are going to discuss these topics in coming sessions. So we shall complete the smart sensors in this session. So a smart transducer is simply expanded as a sensing, monitoring, and remote transmission transducer. So that is a smart transducer or sensor. It can be either analog type or digital type, which can be combined with a processing unit, and this processing unit is nothing but a signal processing unit and a communication interface. So these sensors can provide an electrical output. When they combined with suitable interfacing devices, these sensors are also called intelligent sensors. So that's why it is called as intelligent, and where these sensors can make the decisions on its own. It can be defined as microprocessor based sensor, which can perform one or more number of functions like logical functions, decision making, two-way communication, etc. It can be simply expressed as sensors plus suitable interfacing circuits. So that is interfacing circuits equal to smart sensors. So smart sensors are different from conventional type sensors due to their special functions such as ranging, calibration, communication with other devices. Features of smart sensors. Special features of smart sensors are listed as here. The automatic ranging, auto calibration of data through inbuilt system, automatic data acquisition system, and the storage of data in local memory of the field device, auto linearization of nonlinear functions, auto correction of offsets, time and temperature drifts, self-tuning control algorithms, easy communication through serial bus. So need to adopt smart sensors. To utilize the following benefits, it is essential to adopt smart sensors in a control systems. No need of bulk cables and connectors. That is, since smart sensors are electronic circuits, there is no need to use any bulk cabling and connectors. Hence overall cost of the system gets reduced. Digital communication, due to the integrated manner, the smart sensors can be the digital communication. They also have inbuilt self-test or diagnostic facility. So enhanced features, smart sensors are having enhanced features like self-calibration computation, fault diagnostics, duplex communication, multi-sensing, etc. Hence, they will be preferred of all kinds of control systems. So these are the preferred systems by all control systems. So reliability, reading, reduced wiring, and the ability to produce self-test and diagnostic make the sensors more reliable to use. Higher SNR, the electrical characteristic problems with the conventional sensors are overcome by the use of smart sensors due to no usage of long transmission cables. So improved linearity when compared with conventional nonlinear characteristics. So reduced offset and automatic calibration are some of the important characteristics of smart sensors. So architecture, a simple architecture and a detailed architecture I will show you in next slide. So a sensing element and a signal conditioning are combined to develop transduction element. So here a sensor plus signal conditioner is equal to normally a transducer. Successive approximation type or dual slope type ADC can be referred based on required conversion time constant. Offset compensation and correction circuits are also provided along with the processor. These circuits are useful for the offset correction and zero compensation purpose against temperature drift. For the data storage and retrieval, memory is also available in these smart sensors. So sensing element, signal conditioner, signal processing through network, you are getting the output here. So that is a smart sensor. So this is a detailed architecture of smart sensor. Here the transducers are connected here through operational amplifiers to sample and hold circuits are used through analog mux and end of conversion and start of conversion to ADC, and these two signals are obtained from the processor. So this is sample and hold circuitry, and compensation circuits are attached to processor, and serial communication to other devices are connected here, and memory and DAC. So this is memory hardware, and this is interfacing hardware, and this is transducer stage. So this is the detailed architecture of smart sensor. So here these are the elements of smart sensor sensing elements. Data acquisition systems, it is DAS. We have seen data acquisition system in detail in earlier unit. It can here sensing elements, sensors along with signal conditioning circuits are simply transducers are used as sensing purpose. They are in contact with the real world signals or measuring systems. Any variables such as temperature, pressure, flow, level, etc. can be measured with them. They are also called a primary sensing part of any measurement system. So data acquisition system, it can be used for the measurement and processing of any real world signal or the variable which is to be measured before being monitored, displayed or recorded. It consists of transducers, amplifiers, sample and hold devices, multiplexers and the analog to digital conversion circuits. So signal processing unit, if sensors are available for transduction purpose, it is necessary to use signal processing units to process the output signals. They will do the process of modifying or manipulating the input signal in such a way that they should meet the requirements for further processing. The process of signal conditioning is carried out by the following steps. One is excitation. I will show you those steps. And next, excitation for passive transducers, it is essential to supply the power. Signal conditioning circuit itself generates excitation or power supply to passive transducers such as strain gauge, RTD, and etc. If RTD is used as sensor for the temperature. So components in smart sensor, the components present in architecture of smart sensor are transduction elements, transducers, interfacing hardwares, data acquisition system, memory hardware, programming devices, communication facilities, compensation facilities. So these are all the components, and we have architecture. There are several amplifiers and sample and hold circuits corresponding to different transducers respectively. To obtain the digital signal, the analog signals are sent to ADC via analog mux multiplexer. Any type of ADC like flash type measurement current excitation source can be used to convert change in resistance based on the temperature variation into measurable voltages. So that is the conversion process, and these are the steps taking place in the architecture. One is amplification for the purpose of increasing the resolution and reducing the noise. Amplifiers are used which will do boosting of input signals. So filtering to remove unwanted noise in terms of frequencies or some other unwanted signals. Components present in the input signals, filters are required. Depending on the input signal, low pass filter, high pass filter can be preferred. Linearization for better response, non-linear responses can be converted into linear responses by means of linear circuits, linearizing circuits. Sampling, the process of conversion of continuous signal into discrete signal is called sampling. So the next component is ADC DAC, analog to digital, digital to analog conversion can be used to convert physical quantity continuous nature into digital quantity, whereas the digital quantity can be converted into continuous analog quantity by means of a digital to analog converter. And then we have sample and hold circuit. Already we have seen sample and hold circuit in detail in earlier unit. Sample and hold circuit is a device which samples voltage of continuously varying analog nature. Further, the value can be held at a constant level for a specific period of time. It, in any ADC circuit, sample and hold circuit can be used to eliminate the variation in the input signal, which corrupts the conversion process. The multiplexer, it is the selection device which selects one of the several analog or digital input signals, and the selected signal will then be followed to a single line. If there are 2 to the power of n inputs have the selector lines, the multiplexer is used to select a particular input signal to be sent to a single line. So it is a line selector. Next are programming devices. After the process of data acquisition process, the processed data output signal is fed to the programming devices such as microprocessor unit for the purpose of programming. The memory for the purpose of storage and retrieval of programmed data, memory unit can be used. So the evolution of smart sensors, the following is the organization of the history of smart sensors. Starts from first generation to the fifth, that is in current generation. The first generation devices had little, if any, electronics associated with them, and second generation devices were part of pure analog systems. There is no question of digital devices at that time. They have virtually connected to its associated electronics available in remote place from the sensor. So here the block diagram of third generation smart sensor. It is we are in now fifth generation. The transducer, signal conditioning, ADC, microcomputer, ROM, and host computer. It is a block diagram of third generation. And here in the third generation devices, transducers and their associated signal conditioning circuits are used as discrete devices. ADC can be used for the conversion of analog input signal into digital output signal. Microprocessor was used for the programming purpose, and ROM was used for the storage and retrieval of data with suitable communication interface facilities. Communication with the host computer was carried out. In the fourth generation, that is shown here, the fourth generation of smart sensing devices, the transducer and signal conditioning devices have combined in a monolithic package. The block diagram of this is shown here. The transducer and signal conditioning unit are combined as a single unit, a single component, and that is the development took place towards fourth generation. And the evolution of smart sensors, here this is the fifth generation. Now we are in this generation. The block diagram of fifth generation smart sensor is shown in figure. Analog with and integrated sensor, analog to digital conversion device. So here PROM, the programmable read-only memory, can be combined with the sensing and conversion unit in monolithic form. The functioning of the overall unit can be carried out easily. So here all together the ROM and this memory unit and sensor and ADC all together are becoming a single unit, and then it is connected to microcomputer, and then it is connected to host computer. So this is the fifth generation, and we are in this generation now. So applications of smart sensors, smart accelerometers for the measurement of acceleration, smart optical sensors for object detection, smart IR detector for any identification presence of products, smart sensor for defect or fractures monitoring in structures or infrastructures. Smart sensors to detect the minerals present in geological areas, food processing and preservation, biological hazard detection, health monitoring and medical diagnostics. So these are the smart sensors applications. So there ends this unit, this topic in this unit. In next session, we will move on to next topic. We will stop here. These are the references, and these are the textbooks, resources, and we stop here. Thank you, students. We will start the next topic in next session. Thank you, students.